Hey everyone, welcome back to the new school year. This is the first lesson of our science class for the coming year. Of course, it has been well over a year since I last taught you guys science, so um, you might see some overlap with the things from last year because I really don't know a lot about what you guys covered last year. Um, you might also see some overlap with the things that I did with you guys a couple of years ago. Um, but just bear with me as we try to sort of figure this out. So before I get started, as I mentioned in the math video, but did not mention in the geography video, I am going to try to um, to to name every lesson using this format at the bottom of the screen here, this U1 L1 sort of system. The U stands for the unit that we're working on, the L stands for the lesson that we're on within that unit. So our introductory unit, which is this one, is Unit 1, and then as we progress through the units, you'll see the number change from U1 to U2 to U3, and we'll go through the different lessons in order as well. So hopefully it'll help you guys find the lesson that you're looking for if you copy down the same title in your notes, because then if you're stuck on something that's in, U2L5, then you can just go on YouTube and look exactly for U2L5 on the channel. Provided that, now, of course, it would be a little bit difficult maybe if you're seeing U2L5 for each of the different subjects, but still, it would hopefully be easier for you guys to figure out what video it is you need based on this new naming convention. Um, I know last year with math, I just numbered all of the lessons, and we got up to something like 56, which I suppose would have worked as well, but I just didn't want the names to become super long because now I have to specify the subject as well. So I'm trying to condense it down to this UL thing. So if that's working, great. And if it's not working, let me know and I'll see if I can find a new way to sort of identify the different lessons. So of course, this is our science class. We're going to be covering a whole bunch of different topics in science. Um, the first topic that we'll cover will be the rest of this Unit 1. It'll just be another lesson or two on the scientific method, how it works, maybe some resources that'll help you guys get a better understanding of the scientific method, perhaps some YouTube videos, um, or I found this new app a couple of weeks ago that lets you read scientific papers all in the same place. It basically builds you a news feed like you might find on Facebook or Instagram, but of scientific papers. So I might throw in something like that towards the end of this scientific method unit, just so you can see what the sort of finished product of a scientific paper looks like. But other than that, we'll just be going through the process of what the scientific method is, why it's important, why we use it, why it's important that we stick to a similar process whenever we're going through the process of scientific discovery. But then after that, we'll get into the major sort of branches of science. So the three sort of big ones are biology, chemistry, and physics. In a Canadian high school, you would take science classes up to grade 10, and then it splits off into biology, chemistry, and physics. And then when you get into university, those things split off into more and more specialized areas. We're going to keep it reasonably broad. I'm going to talk about biology, chemistry, and physics, but I'm also going to throw in geology and earth science as one unit, and astronomy and space science as another unit. So basically, we'll be talking about 5 major areas of science. We'll be talking about biology, chemistry, geology, physics, and astronomy. So we'll cover all 5 of those and in this order. I'm going to break down each of these so that you know what to expect in the slides to come. So our first unit is going to be on the scientific method. So we'll look at the different components, the different steps of the scientific method. We'll look at what constitutes science. What does it mean for something to be scientific? What does it mean for something to not be scientific? When people will make an argument or a hypothesis that can be tested with an experiment, is that all it needs to be scientific? or is there more to it? Is it something that has to be tested with an experiment that anybody can conduct, or only those with specialized equipment? What counts? We'll get to all of that in the coming lessons. And we'll also talk a little bit about why it's important to follow the scientific method, or at least why it's important to follow a method of some sort that we can all reasonably agree upon when we're going through this process. We are living in a time where there are a lot of people that aren't paying enough attention to the data that's coming in from scientists and from scientific experiments and papers and stuff. So we're going to look at why it's important to follow that method, and or at least to follow a method that's as rigorous, as detailed and methodical as the scientific method that we're going to discuss, in order to get reliable and accurate results that we can then use in our daily life and in society. So after that, we're going to get to unit number 2, which is biology. And in this one, we're going to spend the first little while classifying living things as using a whole bunch of different classifications. So first, we'll break them down by the major kingdoms, like the animal kingdom and the plant kingdom and so on. But we'll also sort of subdivide that. We'll divide the animals into vertebrates and invertebrates, and things like that. So we'll classify um, different organisms in a whole bunch of different ways in the first few lessons. Then, of course, that classification, like I was just saying with the vertebrates and invertebrates, sort of focuses more on the animal side of it. So then after that, we're going to take a step back and we'll look at the plant side of it. Not so much in terms of classification, but in terms of how plants work, how photosynthesis works, things like that. We'll spend a couple of classes on that as well. And then we'll move on to biomes around the world, and what distinguishes one biome from another. Then that'll lead us into ecology, where we'll talk about things like food chains and food webs and different types of animals that are in the food chain and how we give them different names. Producers and consumers, things that make their own food using, for example, the sun, versus consumers, things that have to eat other organisms in order to gain energy. And then we'll round off ecology by talking about the carbon cycle and the nitrogen cycle, just the way that certain things are cycled around through organisms and through the environment, based on the things that we're going to end up discussing. And then we'll round off the biology unit by discussing pollution and environmental challenges, because there are changes happening in the world that are affecting ecosystems and disrupting food chains and food webs, and it's going to become a much bigger problem. So it's important to understand how the things that we study earlier on in this unit are changing or are being affected in some way by pollution and climate change and things like that that we're seeing in the world today. So after that, we're going to get into chemistry. I'm keeping the chemistry unit reasonably simplistic, mostly because it's probably the unit that I've spent the most time away from since high school. Um, so in terms of this unit, what you can expect to see, we'll discuss a little bit about some simple things, states of matter and changes of state. We'll talk about different ways to classify matter and solutions and mixtures and things like that. Then we'll move on to the structure of the atom, what an atom is made of, and what those things, what properties those constituent particles have. After that, we'll move on to the periodic table, which you can see right down here. We'll talk about the setup of the periodic table, a little bit about the history of the periodic table. A couple of years ago, the last few elements in the periodic table down here, these last 4, were all given names. So that's something that's been happening fairly recently. And we'll get into a little bit about bonding and drawing in atoms on paper and how to draw in the interactions that atoms have with each other in a way that makes sense. So we'll spend a lot of the time in this unit looking at atoms and how atoms of one element interact with atoms of a different element, how they can combine to form new compounds. And then we'll end off this unit by discussing acids and bases, which is very much a chemistry subject that you would see in high school. So hopefully we'll have enough time to get through all of these things. I apologize that it's a little bit simplistic, but I want to make sure that I'm focusing on the things that I have studied the most and know the most about, and chemistry is not one of those. So once we've gotten through biology and chemistry, we'll finally hit Unit 4, which is geology and earth science. I took an earth science course just this past summer, so hopefully my knowledge on the subject is fresh enough and up to date and accurate, and in general just good enough that I can give you guys some really insightful lessons on a whole bunch of different topics here. So you can see there's a whole bunch of stuff listed here. We'll start with the hydrologic cycle, which is basically the water cycle. We'll look at different types of rocks, and we'll look at the rock cycle itself. So lots of cycles going on in this course. First we had the carbon and nitrogen cycles, now we've got the hydrologic and rock cycles. Then we'll look at the tectonic cycle, which is plate tectonics, different types of plates, or different types of plate boundaries, how they move, what happens when two plates collide in a certain way. And then, as you guys might remember from a couple of years back, we'll look at geologic time. So things that have happened, hundreds of millions of years ago, billions of years ago in history, and how we can learn from that information to make predictions about the future of our planet. Then we'll look at some mass extinction events. We won't really examine the details of those extinction events because in a lot of ways there are things we still don't know about them, but we'll look at how we know that there have been mass extinction events, and how that'll hopefully give us a better idea of how we can gain information in general by just looking at rocks, looking at really, really old rocks, and how to figure out what's exactly been going on in our planet's history. Then we'll round off this unit by looking a little bit at astrogeology. I'm throwing it in maybe here, maybe I'll throw it into our astronomy unit towards the end. I want to focus on this just a little bit because there has been some exploration stuff of other objects in our solar system, in the asteroid belt and Pluto and so on, in pretty recent years. Plus, astronomy is sort of my forte out of all of these units, so I'm really looking forward to talking a little bit about astrogeology and stuff with you guys. After that, we will get into our fifth unit, which is physics. We're going to try and keep it fairly simple in terms of the math and the equations and stuff. But we will start by just looking at motion and forces, what they are, how they work. We'll look at different ways to describe them. So for example, for motion, we'll look at distance and speed and velocity and acceleration. What's the difference between speed and velocity? How does gravity work? What are Newton's laws? How do they help us solve problems involving motion or forces? So we'll start off with that basic stuff, which I say basic, that's like grade 11 stuff here, so it's not the most basic thing that it could be. But that only goes up to about this red line here. Everything below this line is more complicated. So we'll, once we get through all of that, just to give you guys a picture of some of the stuff that's been happening in physics today, we'll look at these last few topics that you can see. So all of the topics above that red line are things that we've known more or less for hundreds of years, and even if they're not perfectly accurate, like Newton's laws, they work well enough that you can use them in your daily life, but they're also not the most interesting things going on in physics today. So that's why I want to give you guys a little bit of insight into what exactly is going on more recently in physics. And the reason I feel ready to do that is because physics is what I'm studying at university, physics and astronomy together. So I'm hoping I can give you guys a good amount of information about these last few topics. So the first one is the four fundamental forces of nature. So those are gravity, electromagnetism, the strong force, and the weak force. So we'll talk about what those are, how they work. We'll talk about the standard model, or also known as the standard model of particle physics. And that's basically looking at the things that make up protons and neutrons, and then some other stuff. So the way chemistry has the periodic table, so you've got every element, and the elements are made up of little bits. The atoms of each element are made up of little bits, protons, neutrons, and electrons. The standard model that we're seeing here in physics is a step deeper than that. We're now looking at the proton, the neutron, the electron, and we're looking at what are the constituent parts of protons and neutrons. Are electrons made up of something smaller, or are electrons sort of their own individual thing? How many different particles are there in this like next level periodic table? Next level being like next smaller level periodic table. So we'll get into some of that, how it works, why it's important, what kind of research is being done with that in the present day. So in labs like CERN and stuff in Switzerland, they're working on things involving the standard model of particle physics. Then we'll round off this sort of complicated stuff by talking about dark matter and dark energy, which are relatively new concepts in physics that we will explore why scientists feel the need to include things like this in their understanding of the universe. We'll explore just how much of the universe is made up of dark matter and dark energy, and why we think that that this needs to sort of exist in order to explain the phenomena that we see in the universe. So the dark matter and dark energy thing in particular really leads us nicely into the astronomy unit that we're going to get into after that. I'm really hoping that we have enough time to get through everything before the end of the school year, because this is sort of my bread and butter. So we'll start off simple. We'll spend a couple of classes looking at the solar system in terms of how the solar system formed, the planets of the solar system, asteroids and comets, what's the deal with Pluto, things like that we'll explore here. We'll look at the life cycle of a star. We'll look at the true size of the universe and just try and wrap our head around how big the universe is and around how big the things in the universe are. So we'll look at maybe some animations of different star size comparisons, and how Earth compares in size to Jupiter, and how that compares in size to the Sun, which compares in size to a different star. We'll look at black holes and how big they are. We'll look at galaxies, how big they are, how far apart they are, and just try and wrap our head around how big the universe really is, or at least the parts of the universe that we can see. And then, of course, as we're talking about the life cycle of a star, part of that involves the stuff that happens when a star dies, which can lead to some pretty cool stuff like white dwarfs, neutron stars, or black holes. And a lot of people, when they think astronomy and they think cool stuff happening in space, they think black holes. So hopefully we can spend a lot of time talking about that. This thing up here, of course, is the first photo of a black hole that was taken a couple of years ago. For those of you who were at the school at that time when I was, you will remember, will hopefully remember seeing this photo released live in a conference in our science class. So that was really cool to see. But we'll explore a little bit more about what black holes are and how they work this year towards the end of our astronomy unit. Then to wrap up, after we've talked about stars, the stellar remnants, all of those things, we'll spend a couple of classes just going over things like space exploration, both historically, things like the space race and going to the moon in the 60s, and all of the different missions that happened, different missions to different planets, the Voyager space probes, things like that, what all of those things that happened in the past, as well as things that have happened very recently or are going to happen in the next few years. So, for example, there was a probe that was launched headed for Mars just a few weeks ago. So we can talk about things like that. We'll talk about future plans to explore different areas of space, plans to get humans on Mars or humans on other objects in the solar system. And then we'll talk about the possibility of life on Mars and in other places in the solar system. There are a couple of moons of Jupiter and Saturn that are looking pretty promising. We'll look at some planets in far off solar systems that that look like they could have life or like they could support life if we just went there. So we'll look at some of that. We'll spend a very, very brief time looking at astrobiology, astrochemistry, and astrogeology. These things tell us more about the history of our solar system or give us clues about what different planets or different atmospheres or different stars are made out of. And so we'll get into how we know those things, how we can look at a planet and how we can look at the light coming that's passing through its atmosphere and see how that tells us about the composition of the atmosphere and whether that is a composition that signals a potential presence of life or just something that's totally toxic and not good for living things as we know it. Then we'll round off the year by talking about the Big Bang and the cosmic microwave background radiation that is sort of evidence of the Big Bang. We'll talk about why this theory seems to make sense, and what we can learn from the cosmic microwave background and how it ties together with other concepts in astronomy and in physics. So for those of you who have worked with me before, you guys know that physics and astronomy is what I study, and this is sort of my area of, I wouldn't say expertise, but I have more knowledge about physics, astronomy, and now geology than I do about biology and chemistry. So if you guys have questions, feel free to ask me for any of them, but if you have some really complicated questions or want to go down a rabbit hole of research, when it comes to geology, physics, or astronomy, let me know and I'll see if I can help you guys out with that. But other than that, I think that covers sort of everything that I was hoping to cover in this class. If there is time for a little bit extra at the end of the year, we will get to that. Maybe go back to topics in physics and cover some really nifty, complicated stuff that's going on in physics these days that doesn't include the things that I already listed with the dark matter and so on. But yeah, so that's about it for my plan for this year. If you guys have any questions, concerns, comments, or if you would like to see something else, just get in touch with me and we'll see if we can sort that out. Otherwise, I will see you guys in the next lesson. Have a good one.